Ma'am, excuse me. Excuse me, ma'am.
Okay, so we are going to take 2 minutes here and then move on to creating something more, maybe one more geometric verification. And then since some of the teachers are teaching higher classes, we'll look at maybe one or two on calculus and calculus concepts. Are we good to go, everybody?
Ma'am, somebody is saying they're not able to get the equation, the final equation of this.
I have demonstrated, I think 3 times now.
Yeah.
So I would suggest that you just hold on to this. I will be sharing a step-by-step handout, which you can then follow and do on your own once again. And maybe in the next activity, if I still need a result like this, I will get back to it. Okay?
And ma'am, sorry, if I could just request
one more activity, and I'm going to open a new file just to get started fresh, right? So let's not save this, and I want to now open a new file, and I want to work again on geometry perspective. So we are going to just look at a small result on geometry, which I think you use many a times in grade 6 and 7 on centers of triangles. Because the whole essence of GeoGebra is to have a certain exploration setup, so that you can make conjectures, students can make certain conjectures, and then they can explore and discover certain results rather than being given those results. So since we have talked about triangle right now, let's see how we can get the centers of the triangle. So I'm looking at a triangle, and we are looking at getting the centroid and orthocenter and incenter and circumcenter of the triangle, and trying to discover some properties or certain relations and seeing as to what these special points are. So can I request all of you to go to file and create a new file. If you want to save your previous work, then please click on save and give a name perhaps to the file and call it to be maybe triangle1 and .ggb as it is by default shown. But do save your result if you want to get back to that later. And open a new file. You need a blank page to work with. Everybody has a new file. Please put it in the chat. Done. Then only we'll start. Otherwise, some of us are left behind, and then it becomes difficult. So please open a new file and say ready or done, and then we move to this one.
Yes, ma'am, getting a lot of time. Kanika ma'am, if you could just remind and request everybody to mute their mics. A lot of echo.
Absolutely. So please, Viva has suggested this, and it will help everybody to pay attention and to hear each other. So please put your mics on mute. Thank you, everyone. Okay, so once you are ready with a blank page, we are going to again explore properties of triangles. So I'm going to start with the polygon tool, and I'm going to click on the drawing pad just to create any triangle. So if I want to first start discovering the points of concurrency of medians, then I will need the midpoints of the sides of the triangle. So if you take the midpoints of the sides of the triangle, I can again remember in the point tool, we had the midpoint somewhere. So I'm going to look at this midpoint or center, select this tool. When you come to the center of the triangle somewhere in the interior, click on that, and you would be able to, no, that didn't work. So I have to click on the sides only. So I'm just going to go back because I clicked on the center. That was wrong. So I'm just going to go and get the triangle and click on the midpoint, right? Select the midpoint tool. Come to the side one by one, and you will be able to get the 3 midpoints. So again, to get the centroid of the triangle, since you all are teaching this, I'm not going to talk about the definition. What we are looking at is getting the line which is joining the vertex to the midpoint of the opposite side, right? And so median AE is constructed. Similarly, I can take median DC. So what I have done is I have taken the segment 2, not the line 2. So with the segment 2, I have got the median. And then you can ask children that, okay, now if I am moving this, any vertex, 2 line segments definitely are going to intersect. What do you think will happen to the third median? Do you think it will intersect these two medians at the same point or not? And then we start verifying that conjecture that yes, if I take the segment and say click on B, then click on F, then we see that as we drag the vertex A or the vertex B, they all seem to be intersecting at the same point. And that is where we come up with the result that the medians of a triangle are concurrent. And we can then identify this particular point. You can choose the intersect tool and you can intersect two medians. And it will give you by default the point named as G. So usually we represent centroid of a triangle with the letter G. So that is the way you would be able to get the centroid of a triangle and also a verification of the result that the medians of a triangle are concurrent. So take 2 minutes, go back to your file and see if you can construct this applet for yourself. And those who have already done it can take another center. So can you get the ortho center in the same triangle? I don't want to go away from this construction. Same triangle if you would like to, then how will you get the ortho center? Any doubts in the chat, Vibha?
No, ma'am, not yet. Oh, there's one coming up. How is the triangle named automatically?
Yeah. So again, these are sometimes the versions that would give you. So if they are not, then you will have to come to options and then labeling. So then you can say the labeling could be automatic, but then when I do it automatic, then all the segments, everything will get marked with the various names, which sometimes are confusing for student. So in the labeling, you can choose new points only. So once you put that selection, then hopefully it will work for you. So once you've got the centroid and you have played by dragging the vertices, then do put in the chat done, and then we can
First, from someone they're saying if you can just guide how to construct a 60-degree angle later on. Yeah.
So right now we are looking at this, and in the same diagram, I'm going to now also get the ortho center. Now, just to keep the construction a little clean, what you can do is, I'm going to hide these medians. Now, this is also an interesting part of Geogebra, that you can hide part of the construction. So when I click on, say, this median CD, then if you do right click and you choose this, deselect this show object, then that median gets removed or hidden, not deleted. When you delete something, then everything that depends on it will also get deleted. Like here, I actually had accidentally clicked on the object, which was the entire triangle that got hidden. So here is this not the entire selection. I want to only select the median. So this median only is selected and it gives me the name as well, and I want to hide that, not the entire selection. So this will hide the median. So this point G is our centroid, which if I want to make it more prominent, I can give it the name in red. I can also change the size of this point just to make it a little prominent. Now this cleans up the picture a little bit. Now ortho orthocenter. How does one get the orthocenter of a triangle? So if we are looking at getting the orthocenter of the triangle, then I need the perpendiculars, right, drawn from the vertex to the opposite side. So we had not used the perpendicular line, but you did see that there is a perpendicular line too. So if I click on this perpendicular line tool, then it tells me, just take the cursor there and it tells you how to use it. It says select point and perpendicular line. So when I select this point, that means the point C, and I select the side on which I want to draw the perpendicular, then I get the perpendicular drawn from C to the opposite side. Similarly, I can do it from A to the side opposite to me. Again, the questions would be, well, two perpendiculars definitely seem to be intersecting. But what happens to the third perpendicular? Will it also pass through this? So again, choose the perpendicular line. Please put the mic on mute. So you will be able to then take B point and then opposite side. So this is where the exploration and conjectures start working. And this one is an interesting one because there is a lot more to be discovered here. The moment I take the point of intersection, and it came up to be the name as H, let's call it blue, and let's also make it bigger so that it's prominent. So now the questions that you can ask children. Do you think this point H will always be inside the triangle? So the point of concurrency, which we call as the orthocenter of a triangle, will it always lie in the interior of the triangle? So you can move the vertices number of times and ask them, oh, what happened? Where did the point go? So you can see that in some situations, the triangle, as you make the triangle to be a special one, the orthocenter is moving out. So that is where we are looking at. If the triangle turns out to be an obtuse angle triangle, we are looking at orthocenter moving out. If it is a right angle triangle, then the orthocenter coincides with one of the vertices. So that is where these explorations and questions can be asked, and you can have children play with it. And in the same one construction, you can get all the centers of the triangle in the sense of the four centers that we teach in grade 6 to 9, that they can be explored right here. So see if you have been able to get the orthocenter of the triangle, and let us know if there is something you want to know about this one before we move on.
Done, ma'am.
Done. Put it in the chat, please. That will help. Great. And if you're done, then you can now explore on your own. What about the angular bisectors? Can we find the perpendicular bisectors? And angular bisectors gives you two other centers. So again, here is where you are looking at angle bisectors. So before we do that, clean up your construction so that these lines are hidden and they don't come in the view right now for us to worry about, and your construction remains easy enough for you to see. You can, of course, always look at the idea that you can make these construction lines to be dashed lines. So that, normally in our math notebook, we do that. I had selected everything. So if I just select this line and I change its properties to dashed line, that also helps us to know that this was the construction. But right now, it might just help if we clean up and not show these lines. So just again, right click and hide. So go right click and then hide, and I again selected the entire region. So again, nothing goes wrong. You can always come back to these little arrows on the top right and do undo from there. So that is a possibility as far as it is concerned. So again, if you have got the hang of this, then we can try something different. But you can have all four centers here and then discover a little more. The Euler's result of three centers of the triangle always fall on a line. So if you have four centers, you can ask the children to keep an eye and see which of the three are always collinear. And that would help, again, let you extend the maths from the textbook to completely another level. So are you getting the hang of centers of triangle? Would you be able to get the angle bisectors, use angle bisectors to get the point of concurrencies and the perpendicular bisectors of the sides as well. So get in center and circumcenter. Those are the 2 points that we are left with. So I would like you to save this applet in your device and then complete this construction for yourself. So get all the 4 centers, and if it helps, you can always, even rename this point G. Instead of being called G, you can give it centroid. So you can actually type the full word here, and then it will be easier for children to see. So this is something that you can do with the naming as well as the display is concerned. So what is the feedback, Vibha ma'am and Renuka ma'am? Are they good to go?
Yes, ma'am. Yes, ma'am. No doubts on that. We're getting a lot of done. So
Yes, ma'am. They want to start with 11th and 12th. Somebody.
Yes. So we have done 2 activities on geometry.
Okay.
So we'll now look at some of the graphing results. Because initially we had
Again,
kind
you
of
forgot.
almost
I
not
think
worked
last
much in
time
the
this is
first
the second
20
time.
minutes, so I'm a little behind my plan.
So you have to
So
remember your
I do
password.
understand some of you
Actually,
are
I'm in
from higher
a
classes, so we will
training
be
session.
looking at
You WhatsApp me, I'll
doing
reset
a
it.
little bit of pre-calculus and
Your
calculus.
user ID.
So if you
You
let
do
me close
remember
this
your
and we
password.
move on to
Don't
looking
forget
at
it.
something on trigonometric functions perhaps. So if you were intrigued after looking at
No,
that
you're
particular
forgetting it.
applet of
It can't be done.
how
What you
the
type, you
trigonometric
will
functions
forget.
were graphed, then maybe we can start
Give the same
exploring right
password
from there.
as you give to your
I hope this
personal
doesn't
ID.
again give you trouble.
And remember one thing: you can click on forget password and you can delete your password.
So again, open a new file,
Okay.
and now we will be in the graphing perspective. So here is where we have a graphing perspective. So we are going to try something on graphs. But before we jump into the trigonometric functions, let's try to again open the input bar and try to see the possibilities that input bar gives in language of the various options that you would be able to get. Oops. Is this troubling me today? So if you go to view input bar and in the graphing perspective, just type in some functions. Functions could be just simply 3x plus 4y equal to 7. So if you are looking at typing in an equation, then it would always help if you think it as a function of x. So instead of 3 plus 4y equal to 7, if you just type in fx is equal to 7 minus 4y, then you would be able to get an equation coming in from there. I again need to restart this. Sometimes is an issue, and today it's bothering more than ever. So just take your time. I'll be back in a second.
Okay, all those who are leaving the meeting, please don't feel there is anything wrong on your end. There is a connectivity issue on Savita ma'am's end. She'll be back soon. So please relax, don't leave the meeting.
Ma'am, excuse me, ma'am. I am able to draw the graph, but how can I get the value just like 0, pi by 2, pi on graphics?
Which graph? What kind of graph have you drawn?
Means just like ma'am said, na, in input bar you type a function and you are able to get the graph. I am typing that and I am able to get the graph of sine function, cos function.
Okay.
But how can I get the value on the x-axis as 0, pi by 4, pi by 6? How can I
yeah, ma'am, I'll just ask ma'am to demonstrate that.
Okay, thank you, ma'am.
So, while Sangeeta sorts that problem out, is there anybody here who is using GeoGebra? We would love to hear what you're doing with it in your classes. I presume there are some people in the poll who said they have been using GeoGebra. So if you can share your experience, it would be really nice.
We've got 2 responses who said they are using it a lot.
I think Sangeeta is back.
Yes.
Yeah. Sorry, I'm extremely sorry. I think it's just getting a little warm out and the device for some reason is working up today.
No problem, ma'am.
Okay, so what we are going to do, you can see my GeoGebra screen.
Not yet.
Not yet? Okay, I'll just check it out.
Ma'am, we have questions related to graphing.
I'm now going to do graphing activity.
All right.
So we are going to be looking at how to use the graphing, that is algebra perspective of GeoGebra, and we are going to look at possibilities.
Your screen is visible, ma'am.
Yes. So one of the things you can always do with GeoGebra is to type in and get functions plotted. So if you look at my input bar, I'm typing in f of x is equal to, and I'm just showing this so that you get introduced to the idea of something a little more than just typing in a function fx is equal to 5 or 5x. But if I do type in fx is equal to just even a directly sine of x, and I press enter, then I do get the graph of sine x function. And we will talk about, since you are using GeoGebra or otherwise as a maths teacher, you would like the maybe x-axis to be in radians. So we will talk about that as well. But before that, something which will bring this whole maths to life is present also from the slider. So I want you to introduce you to the slider. So if I click on slider here and I click here, it starts with a say name A, and it's taking values from -5 to 5 with an increment 0.05. So I don't touch any of these settings right now and I say apply. Then what this slider actually is doing is, it's basically a variable, a parameter. So if instead of sine of x, I want this function to be dependent on 2 parameters, say a and b, then I can actually use these values. So if now I type in another function, say gx, which is equal to ax, a times x plus b. So you can see this a and b are coming in loop, which basically means picking the values that I have given a, and now you can see the actual that life coming to the function. You can see that the sliders play a very big role in graphing. So you can change these parameters a and b, and as a changes, you can again talk to the students in the language of the maths as well. What's happening to the graph? So in the case of the linear function, we are looking at the slope. The coefficient of x is changing, and that is what decides the slope. Whereas b changing, it is changing the intercepts. So when you talk about these in a theoretical form, the sense is not clear to the children as to what exactly is happening. But here you can actually show them that b, as you change, the line is making different intercepts on the x and the y axis, and that is the effect of the constant b in the equation. And a is playing the effect of the slope, the coefficient of x, when I have written the equation in the form of y is equal to mx plus b. So that is the beauty of having something like this, which you can use as a parameter, where the parameter is changing its values, and there are factors affecting which are dependent on it, or functions which are depending on it, which are also changing. So this is something which you can try at every level. It doesn't have to be 11th and 12th. In other classes also, we talk about lines, system of equations are coincident, which are dependent. So how do we get those system of equations? Is by using the fact that I can have actually A1 plus B1. So I can have these into the middle. So I actually A, and I will say underscore, and that will give me the S. Explore when do they have infinite solution or no solution. So those kind of a dynamic applets can be made using the feature of slider. Coming to just with a focus on trigonometric functions. So again, if you are not teaching 11th and 12th, then also I would advise you to pay attention. It is not something totally unique to, or something which would not help you to understand. It will give you some ideas of what you are doing otherwise. So I'm going to try and squeeze in two results right now. One is, how do we show the formation of trigonometric functions to the children? And also for ourselves, sometimes whatever books that we have read and studied, they did not bring this dynamic visualization in front of us. And the second will be, how do we use GeoGebra to make students understand the concept of derivative as slope of the tangent, as one of you had wanted to know about the tangent. So starting with trigonometric functions, we are going to construct trigonometric graphs right from the scratch by the definition. So I'm going to plot a circle with the center and origin and the radius 1 unit. So to do that, what I'm going to do, I'm going to start with 2 points. One is the origin itself here, and the other point is going to be at 1. That means it's going to be a point with the coordinates 1, 0, and A is 0, 0. So I'm going to get my unit circle in the diagram. So I'll choose the circle with center through point, that is the tool. And so if you had not used this tool earlier, you can see circle also has number of options. So you can, in the meanwhile, if you are not interested in this, you can try one of the circle properties and website. But let's try to do this circle center through point. That is what I have chosen. And every time you want to learn how to get the cursor to it, you will be able to get the instructions. So it says select center point on. I'm going to select the point A, and then as you slowly drag, right, your mouse around, you will be able to come to the point B. The moment you come to the point B, you will click again, so that the circle is now passing through the point B. If this is not going to get clicked with it, what will happen is, if I try to change the point B, which is not going to move because I have mounted it to be 1, 0. It's a fixed point. This should not stay, should not fall apart. It should not get detached. That is important for us. So get a circle with a center at origin and radius 1. So there could be 2-3 days of doing this. This is one. Second thing I'm going to do now is, so if you are able to do that, I'm going to take another point and mark it on the circle. So again, notice that the moment I the point closer to it, the circle to mark a point on the circle, the cursor to the circle gets highlighted. Then only you will click it. Otherwise, it will not mark the point on the circle. So can you come to these two steps? Get a circle with center and origin and radius 1 and mark any point on the circumference of the circle. Take a minute and do it for yourself. Do we have any response?
Yes, ma'am. We're starting to get responses. They are able to do it, and there's a query about inverse trigonometric functions.
Yeah, we can't cover everything in one day.
This thing, everybody, not everybody, we have started getting responses.
We cannot do everything in one day. We'll have to do. Yeah, the query is ringing at the back, so you can have the mic. Thank you. Can you please check
Miss Deepa, you do it yourself? Now it's off. I think Miss Sheetal is, yeah.
Okay, so I think we are now good to go.
Yes, ma'am.
Yeah. Okay, so let's try to focus on this. We've got a circle, we've got a point 1, 0 and a movable point. Remember, this point C should move. This point must be on the circumference of the circle. Now, once you have that, then we are going to get an arc from B to C. So for that, come to the center circle tool and look for a circular arc. So we are looking at a circular arc, the tool which will give us an arc from B to C. Again, see how it can be used. We will select center and 2 points. So center was this point A, and then in the order, I want an arc going from B to C. And before we move ahead, I'm going to just make this a little prominent so that it is easy to distinguish it from the circumference of the circle. So get this circular arc, because this is an important step. I'm going to ask you to do this, and then we are almost halfway done. You won't believe it, we are almost halfway done to get our trigonometric functions. So again, remember that when we define trigonometric functions in reference to the unit circle, then the arc length is the arc angle. So I need the arc length here, which is actually automatically calculated. If you see the algebra view, it's giving you D 0.04. So this D is actually nothing but the length of this. If I now move this point along, you can see that the arc length is. So the circle. So just look for circular arc. will ask you to select the center and then the point. B, C, not C, B. Once you have that, you see an instruction something like this. Let me know if you have reached up to that point. Are we able to?
No responses as of now, ma'am.
Do let us know in case there is any doubt or you're lost. I can repeat.
There's a request to repeat.
So get the first we got the circle, the center at origin and radius 1. So we had the center 1, 0, 0, circle and a point 1, 0. We took the circle 2 and we draw the circle with center through point. I hope that everybody had done. Now to
yes, that was clear, only the arc part.
Right. So to get the arc, again go to the circle tool. Look for circular arc. So in the circular arc, the moment you click on circular arc, it says select center and 2 points. So that is already marked. So you will click on center and then you will come to the point B and this is moving that points. It will give you this circle arc. Are we done?
Yes, ma'am. We have started sitting. Yes,
yes, yes. Good. Now, typically, we are almost done. To get the sine curve, the sine x, as we defined, is always going to be in terms of the y coordinate of the point that is making an angle x. So, if this arc BC is making an angle along with we call it as the center, then that angle is measured in 0.18. So to what are sine locus and it to type in, so I use the circular bracket. I'm going to type in D. D is the angle dependent variable and dependent on that is the y coordinate of the point C. So this is very important as to what I am doing here, and it is coming from the idea that this is how we define our sine function. So sine function is going to be mapped between the arc angle and the y coordinate of the point. So if I take that and I press enter, focus on my screen for a second, I've got a new point E. And now if I change the values or position of point C along the circle, keep an eye on this E. Where is this E going? So we focus that, able to see that you change the placement of this so that you can see it clearly. So now keep an eye on the point C, and as I point C, E is moving, following a certain path. Are we able to recognize that path? And to get a better picture of that, we are able to trace this path. So this is where you get all that fun coming in. So when I select point, right click on the point and I say trace on. And if I move this point behind that trace, which we recognize and define as a sine. So this is the way you will be able to point, which is focus pi by 2's and pi multiples in the x-axis. So I'll come to that. Can you first get this point? So can you get the point which is moving? That is Can you plot? I'm putting it in the input bar again. In the input bar, start with the circular brackets from your keyboard. You press only one circular left bracket with the pair of brackets, and within this you will type in D. D is the name of the arc angle. D, comma, Y, brackets, and then C. You will take that point. If Y has C, then I will take Y coordinates. This is important. Once you're decided, now to see how is right click on the point and have the trace on. That will give you the locus of the point. And you can of course change its display properties. So you
Yes, we have started getting now.
Yes.
oh good.
Yes, ma'am. They are good trace.
Yes,
Great.
started getting there.
And so let's, before we talk about tan function perhaps, let's do a right click on any empty space here, and then you can click on graphics. This is to change the labeling and the marks on the x-axis to radians. So come to the drawing pad, do a right click and click open graphics. When you click open graphics, you will get all the settings of the graphics. So in this settings, we are going to change the x-axis set. Right now it is showing x-axis and some numbers. But if I click on this distance and I choose the distance to be multiples of pi by 2, then all the ticks on the x-axis will now come as the multiples of pi by 2. So again, right click in the drawing pad, graphics properties will open up. In the dialog box, it by default starts with this basic. You will click on x-axis and then you will click on distance pi by 2. So click on distance, it was showing number 1. We will not need number 1, but you will select pi by 2. And that is how, so once it's done, just close it. And all your numbers on the x-axis are now multiple of pi by 2. So that is, as simple as that, but it gives a better picture now. Now that you are moving the point along the circle, then these graphs start making better sense that at pi by 2, the sine function is taking the maximum value and the cosine function is coming 0 and the cycle is getting completed. So all that starts becoming very important. It's tough. So that the reduction of function can be explained all the properties of sine as in the first quadrant. Now in the first quadrant, the point C is actually on the first quadrant. The moment I come here, now the point C is in the second quadrant. So x is negative and the y coordinate of this is positive. And therefore sine of that angle will be positive, but the cosine will be negative. So a lot of things can be explained just which you can do step by step. You just type in D, y coordinate of C. C is the point divided. So just here, you would be able to get a point D. And now from here, you are able to trace this point and you will be able to see how the point G is below. So I'm going to again put the trace on for G and then see how it behaves. So I'm going to select G and trace on and also change with maybe properties. And now if I move this point, you will see how lovely it starts looking in terms of the discontinuous functions that we are looking at coming as the function. So this only is a you can get x. So when you type tan of x, are always and so on, and you thought about it, an increasing function and many other things. The moment you have the graph, then it becomes easier to do this exploration and explanation with us. So I'm looking at the time, it's 5 o'clock. So Deepthi ma'am, if you're around, can you give me some idea if, I don't think I can actually finish all that I had planned, but since we were looking at, a little bit of a discussion on ego as well, what do you think? Deepthi ma'am, would you advise?
So, thank you so much, Sangeeta. This was like really visual, and I think we will stop and request everybody to remain on their own. Had one question on as an instructional tool wherein the teacher is explaining and the child looking at it. Is there a way where the children can all do assignments on this and send it to the teacher?
Absolutely, absolutely. That is where I have to take you back to the website of Geogebra. So this is the Geogebra website which you all must explore after today. And in this website, you can create your account first of all. Where you can see the screen.
Yeah.
Yes, ma'am. Yes, ma'am.
Yeah. So here is where you must create an account for yourself. This is full of resources, which are, as we started with saying, it's an open source. It's a repository of resources which educators all across the world have made, and they are free to use. and you can assignment any activity from, and now they have actually classified them in worlds so that it's easier for teachers to select the particular activity, and within the geometry they would give you so many activities. So if you pick any one of them that you like and you want children to experience and do it, then there is a possibility of sharing this activity. So when you click on share, then you can assign these activities through Google Classroom as well.
Wow.
And these are very well integrated with Google Classroom in the sense of that many of them, you can turn them into not just an applet, but an entire worksheet. And there can be some questions and answers thrown in, and you can have responding to, observing, and answering, then they can turn it back in. And this is learning videos, those you must explore and all free to use. You also see them. You can edit any one of them, and you can see that you can add your own touch to it. You can delete part of it. You can add a new applet to it. There's a complete new world that you can open up from here for your students. So definitely this is much to do for any one of us.
This is really useful, Sangeeta. I think we should stop GeoGebra here, and if you can just give us a 10-15 minutes of your time to explain the add-on equation.
Right. So when we are looking at the concept of, this of course is a completely different what you're looking at also the possibility and the requirement right now is to create content. Simple typing you are doing. That is for math teachers a completely different world data. So from the website help.com, and this is a tool which you need to show hands on. I had added a 2 minutes video here which I'm going to try and play and see if you can hear. I hope, because I haven't opened it in Chrome tab, so I'm just going to give it a go and see if it works for you.
In today's classrooms, students are more likely to pick up their devices rather than a pen and paper to complete an assignment. But what about math and STEM subjects? Have they been left behind in today's interactive, collaborative world? Teachers and students still rely on classroom and physical to their work. That's because writing instructions digitally has always been hard. Until now, at least down to more effective learning all subjects. Finally, math extension takes the pain out of creating equations, graphs, and math quizzes. Simply type or handwrite virtually any expression directly on your keyboard or touchscreen, and Equatio will convert it into accurate digital math. Not sure what expression to use? Equatio can help, instantly turning your thoughts into clear on-screen formulas. And it listens, too. When you dictate a formula aloud, Equatio is smart enough to ignore any ers, and other non-words. V equals pi r squared. For a test, no problem. Seamless integration with Google Forms makes it a to do math quizzes. Take their own to show the teachers that just a worksheet much more than a pen and paper. Equatio makes math and other STEM subjects more engaging and rewarding for every student. Try Equatio today and make math digital in your classroom.
So I hope you could hear it clearly, but you can always go back to that later. But what Equatio does is, it's a Chrome extension and there are a lot of features in it. So there is an equation editor, there's a speech input, there's an also space, which is really possibly are teaching or learning nowadays. Which the Desmos graph be inserted through our editor, and of course the handwriting recognition. If you have touch screen device or the stylus, we run these are things that come to extension which you can explore. Just have to go to. I'm not going to show this video back, or maybe let me try. So this is in case you're unfamiliar with how to get the Chrome extension.
To get started with getting Equatio for Google Apps, go to Chrome Web Store. So sign in with your Gmail account and look for the Chrome Web Store, or go for chrome.google.com/web store. As you open the web store, you will find various extensions. You type in Equatio, the very first extension that shows up here. This no, give it the permission to read and digital as soon as it.
So Equatio is an extension which you can pick up from the Chrome Web Store. And if you see my Chrome bar here, you can see there is an extension added in right here. So if I want to, for example, in this there and equal to 0 or any equation that I want, I can have that coming in. So, and I can also add some colors. So I can just select this text and I can add a certain color to it just for the sake of clarity. If I wish to have certain turning into a little very useful and more useful. We are looking at it being used in then of course you would be required to have a premium subscription, and that is again not that challenging. They made it free, not in the current situation but otherwise for educators all across the world. So you just have to submit a form, registration form, which you can find on texthelp.com website, and there you will be able to register as an educator provided you have a school email ID. So if your school has given you email IDs, you will have to give the details of that, and then in a Google form, when your Chrome extension is you will find the blue dots coming up, which is nothing but the sign of the equation editor. And then if I want to type in a math question here, I'll click on that and the equation editor toolbar opens up. So again, I can choose equation editor. I can also choose to insert a graph. So if I open the graph editor, then it opens in the Desmos mode. So shows me all of this. So even the Greek letter mu, right? 2 by 3, and I have a 4 by 7, and I can have something like this inserted just as it is. So again, this is something which you definitely need to explore. For the 90 days, you will get the free subscription. But if you want it to be used on Google Forms, then you will need a premium subscription. But on Google Docs and Slides, it will still work with a regular subscription. So you should go to the website texthelp.com and look for the form where you can add it.
Ma'am, can you please repeat that? Where to go? Where to go?
Yeah, so Sangeeta, we will be sharing recording with the participants here today. I think we have overshot the timing, and we do value your time as well. I think I just have one quick question, that if you are using this as a teacher and the children have to respond with an equation, do they also need to have it as the Chrome extension?
Yes, they do need that Chrome extension.
Yeah. So that clarity should be there.
Yeah.
So everybody in the school pane, if they can do it from the school admin support and then push it on to the student profiles and the teacher profiles.
Absolutely. All devices managed with the school, they can have the access, and students' accounts can get the access.
Yeah. So thank you so much, Sangeeta, for all the creative ways of showcasing mathematics to children, and I really love the fact that whatever is conceptually clear becomes more it becomes clearer when you see it in the real concrete form rather than the abstract form that we talk about in textbooks and getting just by speaking. So this concrete form was like really fantastic, and I love the way the graphs move. So thank you so much for an engaging session, and we really look forward for more. There are already demands coming in on my phone where people are saying, "Ma'am, have another session by her very soon." So, I know you are a very, very busy woman, but we will try and catch you. And thank you, everybody. I have more than 28 schools who have joined in today from all over India. So thank you so much for joining in, and we really do appreciate the work that you're doing in these challenging times. So keep up the good work. Thank you, everybody.
Thank you.
Thank you, Sangeeta, once again.
Thank you. Thank you so much. Thank you for joining.
Thanks a lot, ma'am.
Thank you, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank you, Viva and Rekha ma'am, for helping out.
Anytime, ma'am.
Thank you, Sangeeta ma'am.
Thank you, ma'am.
Thank you, Viva ma'am.
Thank you for joining in.